Today, I want to report on some pretty wild news. Some research was presented in Liverpool earlier this month as part of a European Week of Science. And the research explored how red dwarf stars might be much more dangerous than researchers previously estimated. A lot of the research into red dwarf stars has shown them to be tantalizingly friendly to theoretical life forms. For example, red dwarf stars are very common, making up about 75% of the stars in our galaxy, and presumably a similar percentage of the stars in the universe. Red dwarf stars are very, very long-lived, with lifespans estimated to be in the trillions of years based on the rate at which they burn their hydrogen fuel. So any life on any orbiting planet would have an extremely long time window to evolve. Red dwarf stars also have a habitable zone, and it's relatively small and close to the star itself, which has some advantages but also some disadvantages. One of the advantages is that the red dwarf star serves as a gravitational shield that protects the planets from asteroids, much like how Jupiter's gravity protects the Earth and the inner solar system. One of the disadvantages is that because the star is so cool and thus its habitable zone is so close, the planet is dangerously exposed to the red dwarf star. It's still a star after all, and even though it's relatively dim and cool, it's still a giant ball of fusion plasma. It can still emit blasts of energy and charged particles. It's still super, super dangerous when you're up close. Now, chances are you might have heard of a CME, or a coronal mass ejection. Now, I'm not going to pretend to be particularly well versed in my astronomy, but as far as I understand it, the behavior of plasma within a star's magnetic field and around its corona can occasionally cause folds or pinches that can cause flares or bridges to form. And these bubble outward and snap and explode, throwing all of this mass in the form of charged particles out into space. If this CME were to wash over a habitable planet in the habitable zone, the surface of that planet would be badly damaged. Some people think that it would be largely survivable. It'd be destructive, but we could live through it. While other people think that it would be just totally destructive, and the surface would be sterilized. But this isn't even the worst part of it. The researchers observed a giant flare coming from the red dwarf star AD Leo, which is about 16 light-years away from Earth, so it's relatively close by. There's a known planet orbiting AD Leo. It's a relatively large planet, and it's orbiting at a distance that's about 2%, or 1/50th, that of the distance between Earth and the Sun. So its orbit is really, really close to AD Leo. The researchers saw that AD Leo's flare didn't actually produce a CME. It didn't come from a CME. And so that's good news for the giant planet in its orbit. It's not being washed with all of these charged particles from the CME. However, the flare did produce a huge flash of X-ray radiation, which was so strong that it would almost certainly sterilize the planet's surface in a flashing moment of nuclear light. This amount of energy would have done extreme, perhaps terminal damage to Earth's surface-based ecology. So who knows how badly the surface of this lonely giant planet orbiting AD Leo was actually scorched. In a press release, the researchers said, and I quote, "Astronomers are mounting a global effort to find Earth-like worlds, and to answer the age-old question of whether we are alone in the universe. With sporadic outbursts of hard X-rays, our work suggests planets around the commonest low-mass stars are not great places for life, at least on dry land," unquote. So a hypothetical Earth 2.0 orbiting a red dwarf star would somehow have to contend with the extreme proximity of these extreme X-ray bursts, and that is certainly a problem for life. Representatives from the Royal Astronomy Society said, quote, "If they are right, then talk of Earth 2.0 may be premature," unquote.